Praise the Lord. चलो बेटा. Hi friends, good day. Hope you're all doing well. Welcome to the ACE Engineering Academy online platform. Here, ACE is one of the most trusted and trusted organization for in the field of engineering education. Hope you all are aware of that. Here we are here for the reason, that's the reason being, we're going to discuss the subject electromagnetic theory, which is targeted for the students who are attending or who are aspiring for KPTCL. I am Vivek Narsampalli. I will going to deal with the electromagnetic fields. Now, before going into the detailed discussion of the syllabus, let us try to see what kind of questions were noticed in the previous papers and what is the exam question patterns. Fine, for especially for this exam. This is a weightage analysis and questions pattern. Especially from this electromagnetic theory, if you observe the previous paper, what you'll notice is 6 to 8 questions are asked. And high quality questions, means relatively high quality. From the previous papers were noticed in the year 2016. And what kind of questions were noticed is directly theory based and formula based questions were noticed. Okay, small concepts, theory based and formula based questions were noticed in the previous papers. Fine. So this is what you can notice from this one. And the syllabus is, you have majorly 3 topics: electrostatics, magnetostatics and time varying fields. Fine. So very short and sweet. So these are the 3 topics what we'll have for our exam: electrostatics and magnetostatics. If you go into the details of this electrostatics, we'll talk about Coulomb's law, expression for the electric field, different types of charge distributions like a point charge, line charge, sheet charge, volume charge, Gauss law, potential concept, capacitor concept, boundary conditions. In the magnetostatics, we'll talk about Biot-Savart's law, different types of current distributions like a line current, sheet current, volume current, Gauss law for magnetism, Ampere's law, inductor, boundary conditions. In the time varying fields, we'll talk about the Faraday's law, Lenz's law, okay? And in the magnetic field also, we'll talk about the magnetic force expression. So these are the subtopics what we have for this electrostatics, magnetostatics and time varying fields. Now what I do here, I'll going to take one topic from the electrostatics and one topic from the magnetostatics, and let us try to understand what kind of understanding we should have regarding some particular topic and what kind of questions patterns were noticed in the previous papers. Okay, so what we'll do here in this session is we're going to discuss a very fundamental law, what is called a Coulomb's law from the electrostatics, and we'll try to define the electric field, and we're going to see some corresponding questions related to those concepts, and we'll try to do the same in the magnetostatics also. Fine. So let us start with one topic. Let us see. Discuss a very fundamental law. Okay, your comments are always welcome. Please comment. Please do comments in the YouTube live so that I'll understand your requirement. I'll get some assessment. Fine. Okay. Yes. Okay. Now let us start with one of the topic, Coulomb's law from this electrostatics. We'll discuss about what is called a Coulomb's law. Coulomb's law is a very fundamental law. You have been learning this one from your childhood in the sense from your high school physics. Okay, so it talks about the force of attraction or repulsion between the two charges. Clear? Yes. See here, as you all know, if they are like charges, they will repel each other. Unlike charges will attract each other. If it is a positive, positive, they will repel. Negative, negative, repel. Positive, negative attract. Negative, positive also attracts. Fine. So the Coulomb's law is a Coulomb experimental result. Coulomb has conducted some different experiments on the charges, and he has came up with some experimental results. Fine. So that is what the Coulomb's law is. Now here we are interested in the scalar form as well as the vector form of the Coulomb's law. Fine. So let us take two charges here to understand this Coulomb's law. Here is a charge Q1. I will write the charge Q as a Q1. Here it is a charge Q2. I am assuming these two charges to be a positive charges. Okay. Now I have kept these two charges in the air or in certain medium. So what happens if these two charges are there? They will exert the force on each other. So this will going to exert the force on this one in this direction. This will going to exert the force on this one in this direction. Clear? Okay. Now let us, for the time being, let us consider only the force on this one due to this one. So what is the force direction? Is a line joining 2 points. This is a force direction. Here it is F12, it is a vector quantity. The distance between these two things is the r. Fine. And the unit vector will going to indicate the direction, only direction. This is a force direction. Suppose let us say if the charge would have somewhere here, if some other charge Q is there, what is the force direction on this one? Line joining 2 points. This is a force direction. This will be the force. So what is the force direction? Line joining 2 points. Fine. Let us focus only on this one here. Let us focus only on this one. And what is this r cap? Small r cap is a unit vector. It talk about only about the direction. The unit vector is given by vector by its magnitude. If I do not write anything here, it is indicating the magnitude. Okay. So other way of writing the magnitude is like this. You can write even like this. Okay. These are the different representations. So what is this Coulomb's law is saying is a very simple thing. Suppose if you want to find out the magnitude of the force between the two charges is proportional to the product of the charges, Q1 into Q2. It is proportional to the product of the charges. The force between the two charges, magnitude is proportional to the product of the charges. Fine. And it is inversely proportional to, according to the Coulomb's law, and it is inversely proportional to the square of the distance between them, 1 by r square. So it is the inverse square law. If you club these two things, what happens? F12 magnitude is proportional to Q1, Q2 divided by r square. And there is a proportionality constant here, which is given by 1 by 4 pi epsilon into Q1, Q2 by r square. Clear? Yes? Now observe carefully. This is a law. Then what is the proportionality constant is 1 by 4 pi epsilon. This epsilon is a medium parameter. Okay? So if you want to write, this is a scalar quantity, units are newtons. Suppose if you want to write in the vector form, F12 is equal to Q1, Q2 divided by 4 pi epsilon into r square. I want to write it as a vector. So what is the direction? A unit vector direction. What is the unit vector? Line joining these 2 points. So this is the direction. Clear? Fine. So what are the units for this one is a Newton. For our mathematical convenience, you can write in the place of unit vector, you can substitute as vector by its magnitude. So F12 is equal to Q1, Q2 divided by 4 pi epsilon. 4 pi epsilon. If I substitute in the place of unit vector, if I substitute vector by its magnitude, this will give rise to vector by its magnitude cube. Remember, it is only for the mathematical convenience. Okay, so what is the actual law? This is the actual law of Coulomb's law. This is the actual expression of the Coulomb's law. Remember, this is only for the mathematical convenience. Don't think that the force is varying as 1 over the distance cube. No, it is only for the mathematical convenience. But there is a vector here, vector by its magnitude cube, or here there is a unit vector. So these observations need to be done. Fine. And what is this one? Epsilon. Epsilon is called permittivity. Epsilon is equal to epsilon naught epsilon r. This is a medium parameter. We should have some separate discussion of this one. This is called permittivity. This is called absolute permittivity. This is called relative permittivity. Fine. So what is this epsilon naught value? Is equal to 1 by 36 pi into 10 to the power of 9. Or you can check out, this will be 8.854 into 10 to the power of minus 12 farad per meter. Okay, fine. And one more thing here, there is a epsilon value, epsilon r value is epsilon r is called relative permittivity, whose value is equal to 1 for the air, and it is greater than 1 for other than air, something like a glass, something like a mica, something like a polyester. Okay, fine. So this is a scalar form, this is a vector form, this is for the mathematical convenience. Clear? Okay. So with this, let us see, these are the concepts required. Just we are discussing one sample, and let us see with this concept how confidently we can address the questions which was appeared in the previous papers. Fine. So here my interest is to show you the model of questions and the level of concepts which are required and which are relevant for our exam preparation. Fine. So now let us see the varieties of question, what kind of questions we have seen. Here is a question. Yes. A charge of 8.85 into 10 to the power of minus 9 coulombs is located in a vacuum at 2, 3, 1, and another charge of 4 pi into 10 to the power of minus 3 coulombs is located at 2, 2, 1. The magnitude of the force between the charges is just asking the magnitude. Fine. Okay. Now observe here. I have given the three forms here. He is just asking the magnitude. If you want, you can draw the diagram here. Some sample diagram, some rough diagram. There is a charge here. How much is the charge? 8.854 into 10 to the power of minus 9 coulombs. And where it is located? 2, 3, 1. And another charge, how much is that? 4 pi into 10 to the power of minus 3 is located at 2, 2, 1. He is asking the force between them. Yes. So what is the magnitude of the force between two charges? Which is equal to Q1 into Q2 divided by 4 pi epsilon naught r square. Why I have taken epsilon naught? Because it is mentioned for the vacuum or a free space or for the air. So epsilon r will be equal to 1. Just substitute all the values properly. Okay. So what is the Q1 here? 8.85 into 10 to the power of minus 9 into what is the other charge? 4 pi into 10 to the power of minus 3 divided by 4 pi into epsilon naught. What is epsilon naught? 8.854. Or simply you can write it as 8.85 into 10 to the power of minus 12 into what is the distance between these 2 points? What is the distance between these 2 points? It is the square root of, from your basics, this point minus this point. 2 minus 2 is 0 square. Plus 2 minus 1 is minus 1 square or simply 1 square. Anyhow, there is a square. Plus 1 minus 1 is 0 square. So here it is square root of 1 square is a 1. Fine. So what are the things you can cancel out here? You can cancel out this part, this part, this part, this part. Here it is 10 to the power of minus 12 by 10 to the power of minus 12, which is equal to 1. So what is the magnitude of the force between these two things? Magnitude of force between these two things is a 1 Newton is the answer. Yes, so 1 Newton is the answer. Option A is the answer. Clear? Very simple and straightforward. Let us try to address one more question here. I am going to turn the page. Here is a question. Yes, these kind of theory kind of questions also seen. Which of the following statements about the force between the two charges is true? Yes, unlike charges repel each other. Unlike charges means what? Positive, negative repel. No, it is wrong statement. Positive, negative attract. Second statement, like charges attract each other. Like charges means what? Positive, positive or negative, negative. What is saying is attract. No, they will repel. No force exists between two unlike charges. If they are unlike charges, positive, negative or negative, positive, is saying that there is no force exists. Wrong statement. A force of repulsion exists between two like charges. Yes. If you take negative, negative or positive, positive, there will be a force of repulsion. Yes. So option D is the correct answer. So like this theory kind of questions also expected. Clear? Let us deal with one more question. Yes. Directly finding the numerical, directly based on the memory based questions, isn't it? Yes. So what is this one? He is asking for what is the permittivity of the free space? What is the permittivity of the free space? There is a minus here. 8.854 into 10 to the power of minus 12. Option B is the answer. Direct, memory based question. You need to remember some values. Okay. Now let us deal with the one more question. This question is related to the statement, concept, law. Okay. So observe the question here, what it is. Which of the following is true with respect to the Coulomb's law? What is the Coulomb's law? Just now, just please write down this Coulomb's law here. Magnitude of the force or vector is equal to Q1 Q2 divided by 4 pi epsilon r square into r cap. This is a law. For the mathematical convenience, you can write it as a vector by its magnitude cube. That is not the law. That is only for the mathematical convenience. Now read out the statements here. The magnitude of the electrostatic force of interaction between the 2 point charges is directly proportional to the scalar multiplication of magnitude of charges. Yes. So the product of two charges. So this first statement is correct. Second statement, the magnitude of electrostatic force of interaction between the 2 point charges is inverse proportional to the square of the distance between them. Yes. So it is inverse proportional to the square of the distance between them. So the second statement is also correct. So then what is the option? C. Both A and B are correct. None of these. So option C is the correct. Clear? Let us take one more question. I will going to turn the page. Let us make this as an interactive session. Please try to comment. Please try to answer the questions. Yes, what is the answer for this one? Just a second. Yes. So these are the some of the questions which are related to the Coulomb's law. Now let us take one more question, one more concept here, and let us try to, as I said earlier, we are going to discuss this electric field concept as well. Okay. Now let us take some electric field concept and let us try to address the questions. Yes, we'll take one more concept here. We have seen the Coulomb's law. Now we'll see electric field concept. The electric field intensity or electric field. How do you define the electric field intensity? Let us see mathematically. And after that, we'll try to interpret this one. There is a charge Q and a other charge Q, small q. The distance between these two things is the R. And what is the unit vector here? Unit vector is R cap. What is the force between these two things is the F. Yes, So what is the force expression according to the Coulomb's law? F is equal to Q into Q divided by 4 pi epsilon R square into R cap. Clear? Now what I'll do, I'll bring this one here. Okay. I'll bring this small q other side. F by Q, which is equal to Q by, okay Dana, I'll go slow. Here it is 4 pi epsilon R square into R cap. Force experienced per unit charge is called electric field. Its units are Newton per Coulomb. Units also very important. Sometimes directly there was a question on the units. Fine. So this is the expression for the electric field. Force experienced per unit charge. Mathematical expression for the electric field. So let me rewrite this one here. So what is the expression for the electric field? E is equal to Q by 4 pi epsilon R square into R cap. Yes. So what is the, mathematically speaking, what is the expression for the electric field? What is the definition for the electric field? Electric force experienced per unit charge. Force per unit charge. Yes. Suppose if you want to get the expression for the force, what you need to do? F is equal to Q into E. Okay, fine. Yes. Now what I'll do, let us focus, try to focus on this one. Just forget about all that story. Suppose if you have a charge, what this equation is saying, let us try to interpret this equation. What this equation is saying, if you have a charge, what is there around that one? Electric field is there. If you have a charge, around this one there is a electric field lines. Okay. So that means this can be written like this. Suppose if you have, and the electric field is in the radial direction. That means if you have a charge, electric field is outwards, 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 outwards. If it is positively charged one, the electric field lines are outwards. If it is negatively charged, electric field lines would be inside, towards the charge. Fine. So here is a charge. Let me try to draw the electric field lines. So the electric field is outwards, 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 outwards. Outwards. So you should understand the minute difference between electric field and electric force. Mathematically speaking, there is no much difference. Force experienced per unit charge is the electric field. Fine. So let us try to get the expression for, suppose if you consider, these are the electric field lines. Let us consider at a distance d1. What happens to the electric field at a distance d1? According to this expression, E1 is equal to Q by 4 pi epsilon d1 square into d1 cap. And what is the force F1? Force is not defined there. Why? Because you have not placed the charge there. To experience the force, there must be a charge. Now let us consider one more point. Let us consider the point D2. What is the electric field here? E2 is equal to, just for the understanding purpose, Q by 4 pi epsilon D2 square into D2 cap. And what is the force F2 is not defined here. Why? Because you have not placed any charge. Suppose let us consider one more point here. Here I have placed some charge Q. So what happens to the electric field E3 at a distance of D3 is equal to Q by 4 pi epsilon D3 square into D3 cap. What is the force here? Force will exist here, F3. So what I want to convey by taking this diagram is, suppose if you have a charge, everywhere there is an electric field. Electric field is there everywhere around the charge. But if you want to experience that one, what you need to do? You need to place the charge, one more charge. So what happens? That field will turn into force. Let me give one simple analogy so that you can easily understand this one. Suppose if you consider the earth surface. Earth surface is surrounded by the gravitational field lines, imaginary lines which are pointing towards the center of the earth. Gravitational field lines are everywhere around the earth surface. But if you want to experience that one, what you need to do? You have to place some small mass here. So what happens? This it will going to pull towards it will going to experience what is called a gravitational force. Okay. So here it is a M. Gravitational force is towards. That is the thing. Okay, fine. So if you have a charge, around this one there is a electric field lines. And if you want to electric field is an imaginary quantity, everywhere it is existing. That means if you have a charge, what is there around this one? There is an electric field. And if you want to experience that one, what you need to do? You have to place some charge. Okay, fine. So mathematically speaking, force experienced per unit charge. So for the calculation purpose, what you need to do? If you want to find out the electric field at some particular point, you need to assume as if there is a unit charge and you need to proceed. But if you want to understand physically what actually the electric field is, the gravitational field is the best example. Earth is surrounded by the imaginary field lines. Gravitational field lines are present everywhere. In the same way, charge is surrounded by the electric field lines. If you want to experience them, you have to place one more charge. So the field will turn into force. In a similar way, what happens with the gravitational field? Earth is surrounded by the imaginary field lines which are called gravitational field lines. If you want to experience that, you need to place some mass so that you can experience the force. Okay, ultimately for our exam, you need to remember this. Anyhow, the electric field lines are inverse proportional to the distance. You are rightly said, Hussein. The field strengths are more here, and if I go away from this one, field strength decreases. That is obvious thing. Fine. So let us see some questions here related to this one. Here is a question. This was one of your previous question. Which of the following represents the electric field map due to combination of two positive charges? If there is only one charge, the electric field lines are outwards. Here there is a positive charge. No. Positive must repel each other, isn't it? Here there is a positive charge, only one charge. Here there are two charges. So the electric field lines which are coming from will be deflected from these two things, isn't it? So the without this one, the electric field lines are like this. But because of the presence of the two charges, what happens? They should repel each other. So the electric field lines from here and electric field lines from here like this. So option C is the answer. Clear? Okay. Let us take one more question. Very good, Hussein. Pirwani. Yes. Let us take one more question. Yes, this was also one of your previous question. In below diagram, the magnitude of the electric field at a point A is E. What is the electric field at a point B in terms of E? So here is some charge is provided. That is what we need to assume. Or without charge also doesn't matter. So here at this point, what is the electric field? Here the electric field E1 is equal to, I will call it as a E1. E1 is equal to E. Where is asking the electric field? Electric field is asking here at E2. How much? The distance from here to here, let us say 1 meter. This is a 1 unit. He has provided the scaling here. It's a first unit, 2 units, 3 units. So here to here it is, for our convenience, I will take it as a 1 meter, nothing wrong. Here to here, I will take it as a 3 meters. Because he has not said anything regarding the distance. Okay, so what happens to this one? How the electric field is dependent on the distance? Just to consider only the magnitude. Or what is the expression for the electric field? E is equal to Q by 4 pi epsilon R square into R cap. It is inverse proportional to the distance square. That's how simple it is. Fine. So here, distance E is inverse proportional to the distance square. So you can write this one as E2 by E1 is equal to R1 by R2. So here E2 is equal to E1. E1 value is E. So E into, there is a square here. R1, how much is R1 we have taken? R square. Or you can take it as a D. If you take this as a D, this will become 3D. So here it is 3 square. So what is this E2? E2 is equal to 1 by 9 into E. You no need to write all these things also, isn't it? If you are good at calculations, isn't it? Just by the inverse, from here itself you can decide. This is E, so you can bring this one E. It is 1 square by 3 square, 1 by 9. There is a factor of 1 by 9. Yes, so what is the answer here? Option A is the answer. 1 by 9 into E. Clear? Okay. Fine. So we have, so far we have seen, this we have already addressed. So far we have seen this electric field, electric force between the two charges and electric field concept. These two topics are related to, these are the very fundamental things which are related to the electrostatics. ఉంది చెక్ చెక్ చెక్. ఒక్క నిమిషం. ఒక్క నిమిషం. Okay, welcome back. Now let us deal some concepts which are related to the magnetostatics. Fine. So now let us take one formula here. Magnetic field due to finite length conductor. So here is a, let us consider current carrying conductor. This is a with the boundaries. It is a finite length conductor which is carrying the current I amperes. Okay, from your basics you know that whenever the current is flowing in this way, there is a magnetic field around this one which is given by the right hand thumb rule. Fine. So, but I want to find out the magnetic field at certain distance here. The distance here is rho. Okay, so I want to find out the magnetic field here at some distance. And the angle made with respect to the corners here. No analysis, nothing, just you need to remember the formula. And this is alpha 1, this is alpha 2, and the perpendicular distance from here to here is rho. Okay, and if the current is flowing in this way, there is a magnetic field around this one which is given like this. This is a magnetic field expression. I will represent the magnetic field with the B phi in the cylindrical coordinate system. Fine. So I want to find out the B phi here. Okay, what is the magnetic field expression? So we will not go into the derivational part which is not required for our exam. Just you need to remember the formula. What is the magnetic field due to the finite length conductor? It is a vector is equal B is equal to mu into I divided by 4 pi rho into sin alpha 1 plus sin alpha 2 into phi cap. That is in the phi direction. Fine. So what is this alpha 1 and alpha 2? Suppose if there is a current carrying conductor, I want to find out the magnetic field here. So you need to see the corner. This is alpha 1, this one is alpha 2. So remember this action. Yes. So you have to remember this action here. So from, if you want to find out the magnetic field here, you need to, from here you need to see the angles here. So this is the angle made with respect to above corner, this is the angle made with respect to below one. Alpha 1, alpha 2. And the distance from here to here is, perpendicular distance is rho. Fine. Okay. Now if you want to get the H vector, D is equal to mu into H. This is called magnetic flux density. This is called magnetic field intensity. So just remove this mu. So H vector is equal to I by 4 pi rho into sin alpha 1 plus sin alpha 2 into phi cap. Clear? Okay. Suppose if it is asking only the scalar quantity, you can remove this unit vector. Clear? So its units are Weber per meter, its units are Weber per meter square, these units are ampere per meter. According to the question you need to deal. This is called magnetization force also, magnetic field intensity, or this is called magnetic flux density. Now let us see some questions here. Just you need to remember this diagram. And you should know what is this I, what is this rho, what is this alpha 1, alpha 2, all these things. Knowing the formula is not enough. You should know that parameters, what they are indicating also. Fine. Let us see some questions here. How confidently we can deal with these questions? Yes, here is a question. A square loop of side D carries a current I. The magnitude of the magnetic field intensity at its geometric center is. Options are given. Let us draw some diagram here. Here is a square loop. Okay? And how the current is, he has not mentioned. There is some current flow. It may be clockwise or anti-clockwise, doesn't matter. And how much is the current flowing? I amperes. And what is the side of this one? The side of this one is E, sorry. He is asking what is the magnetic field here at the geometric center. What happens to the magnetic field at the geometric center? There are 4 sections are there. Due to this section, due to this section, due to this section, due to this section. But you no need to do because of the 4 sections. You have to do only because of 1 section and you need to multiply with the number 4. Why? Because the magnetic field due to this section is like this. Magnetic field due to this section is like this, like this, like this. So at the center, it will going to add up because of all the 4 sections. Clear? Okay. So how can you find out the magnetic field due to this single section? You need to see from here, you need to see the corners. Fine. Suppose if you see the corners here, and the distance from here to here, this is the angle alpha 1. This angle is pi by 4. This angle will be pi by 4. And what is the distance from here to here is d by 2. Isn't it? So due to each section, so the magnetic field is like this, like this, like this, like this. So I'll find out the magnetic field only due to one section. And I'll multiply with the number. I'll call it as a due to each section, Hs is equal to, what is the formula? I by 4 pi rho into sin alpha 1 plus sin alpha 2. Is just asking only the magnitude. Clear? So what happens to this one? Hs is equal to I by 4 pi rho. How much is the distance from here to here? Perpendicular distance d by 2 in this problem. Into sin alpha 1. That means 45 degrees, 45 degrees. How much is the sin 45? 1 by root 2 plus 1 by root 2. Now do these calculations here. So Hs is equal to I by 4 pi d into 2 root 2. This can be written as root 2 into I divided by pi d. Pi 4 pi d. But this is a magnetic field due to one section. So if you want to get the overall magnetic field at the center, you need to multiply with the number 4. 4 into Hs. So here it is 4 into root 2. Just a second, just a second. Let me correct myself. 2 will cancel out. Hs is equal to I by 2 pi d into 2 by root 2. 2 will cancel out. Here it is I by root 2 into pi d. So H total, this is a magnetic field due to each section. If you want to find out the overall magnetic field due to all the sections, you need to multiply with the 4. So here it is 4I by root 2 pi d. So this will become, this can be written as, 4 can be written as root 2 into root 2 into 2 into I by pi d. Isn't it? root 2 into pi d. So here it is 2 root 2 I by pi d. So this is a regular procedure. You need to go by the section by section. 2 root 2 I by pi d. Option A is the answer. Isn't it? It is a looking very lengthy. But the concept remains this one. So this is section, this section, this section, this section, 4 sections. You need to do it for each section and you need to multiply with the number 4. But there is one direct formula, direct shortcut you can say, which will save our time. Okay? So what is that formula need to be remembered? This is a formula. I'm going to write here. So what is the note need to be remembered if those kind of questions are given? For n equal sided polygon with side D and carrying the current I, the magnitude of magnetic field intensity at its geometric center is directly given by, no need to take section by section, is given by H is equal to n into I by pi d tan of 180 by n into sine of 180 by n. This is the thing need to be remembered. This will going to save our time. So for equilateral triangle, n value is 3. For the square, n value is 4. For the hexagonal, n value is 6. Polygon with 4 equal sided is nothing but a square. The polygon with 3 equal sided is an equilateral triangle. So in the previous problem, what we have seen is a 4 equal sided. It is a square loop, isn't it? Now let us use this formula again. This formula will going to save our time. I am going to turn the page. Let us take some examples here. Suppose the current carrying conductor is something like this. N value is 3. That means the current is flowing like this. Here it is I ampere and the side is D. What happens to the magnetic field at the center? So directly H is equal to 3I by pi d into tan 180 by 3. What is tan 180 by 3? Tan 60 into sine 180 by 3, sine 60. So which is equal to 3 into I by pi d. Tan 180 by tan 60 is root 3 into this one root 3 by 2. So root 3 into root 3 is a 3. There is one more 3. There is a 9. So which is equal to 9I by 2 pi d. Okay, fine. Now let us take our own example, which I have taken as a question. Suppose if the n value is 4 and the current here flowing is I amperes. What is the magnetic field at the center? You no need to do section by section, it is a waste of time. Directly you can use this formula. What it is? 4I by pi d. Tan 180 by 4, it is tan of 45 degrees. Sine 180 by 4, sine of 45 degrees. Over. So here it is 4I by pi d into 1 into 1 by root 2. So how much is this? This will become 2 root 2 I by pi d. Array, the same thing we have got. Let me go back. Two root 2 I by pi d, isn't it? You don't need to do all these things. Directly, if you can remember this formula, this is a shortcut. This will going to save our time. Directly. Clear? Let us take one more example. Hexagonal, this is. N is equal to 6. Okay, how much current is flowing? I amperes. What happens to the magnetic field at the center? How much is that? H is equal to direct formula. Otherwise, you need to deal with the total 6 sections. Each section multiplied with the 6 lengthy. 6I by pi d. Here the side is d into tan of 180 by 6. It is tan 30 degrees into sine 30 degrees. So here it is 6I by pi d tan 1 by root 3 into this one 1 by 2. So here it is 6 by 2 is 3. 3 divided by root 3 is root 3 I by pi d is the answer. Units are ampere per meter. Clear? Yes? Fine. Let us take, this was one of your previous question. Yes? Magnetizing force. Magnetizing, one of the previous question from other exam, SSC JE. Magnetizing force at the center of the square loop, square of arm of side, here 2A, length shown in the below figure is. So the side is 2A and how much current? I amperes current is flowing. So what happens to the magnetic field at the center? Direct formula. N, how many sides are there? 4 sides. 4I by pi d. What is the side here? Side here is 2A. Side need not be always D. Into tan 45 sin 45. So how much is this? This 2 will cancel out. 2I by pi d. Pi A into 1 into 1 by root 2. So here this root 2 will remain. Root 2I by pi A. Root 2I by pi A is the answer. Option A is the answer. Okay, fine. Let us proceed further. That is a magnetic field due to the finite length conductor. We'll take one more thing. Magnetic field due to the infinite length conductor. You can obtain it from the finite length conductor. So infinite length conductor means what? Like this. These arrows are showing that it is extending up to infinity, minus infinite to plus infinite. How much current it is flowing? Some I amperes current is flowing. I want to find out the magnetic field here at a distance of rho. Here is a magnetic field I want to find out. So if the current is flowing like this, there is a magnetic field around this. Yes? Very good. Then what happens to the magnetic field here? It is an infinite length one. In the previous problem, what I have said, suppose if it is a finite length conductor, the angle made with respect to the corners is a alpha 1 and alpha 2. Then what happens to the alpha 1 and alpha 2? It is an infinite length one. From here I want to see the corner. Can I see the corner? No. This will become 90 degrees. I am trying to see the corner here. I cannot see. This is alpha 1 and this one is alpha 2. So what is the modifications you have to do for the previous problem, previous formula? Alpha 1 and alpha 2 is equal to 90 degrees. So what happens to the B? B is equal to mu I by 4 pi rho into sine of 90 degrees plus sine of 90 degrees. The angle here is phi cap. So sine 90 is 1, 1 plus 1 is 2. Already here 4 is there. So B is equal to mu I by 2 pi rho into phi cap. And if you want to get the H vector, we know that B is equal to mu into H. So H is equal to I by 2 pi rho into phi cap. So the infinite length formula is obtained from the finite length formula by doing some small modification. So these are the formulas need to be remembered. Clear? Now let us see, based on this concept, how confidently we can address the questions. Clear? Let us take some questions here. Here is a question. Yes. Directly, he may ask you to identify the equation, expression, formula. H is equal to is the expression for the magnetic field due to an infinite linear current carrying conductor. What it is? What is the H value? H value is equal to vector, if you write, I by 2 pi rho phi cap. If you take only the scalar quantity, I by 2 pi rho or r or whatever it may be according to the question. Fine. So what it is? Option B is the answer. I by 2 pi r. Clear? Let us take one more question. Come on, try to answer this question. Yes. I want answers from your side. Come on, speak out. A long straight wire carries a current of 10 amperes. At what distance the magnetic field H is equal to 1 ampere per meter? Is asking the distance. Yes. Straight long wire. Long wire, you have to assume it as an infinite line. So what is the magnetic field? H is equal to I by 2 pi rho into phi cap. Just if you take the magnitude, I by 2 pi rho. Magnetic field is given, current is also given, he is asking the distance. What is the distance? Rho is equal to I by 2 pi into H. So how much is the current? 10 amperes divided by 2 pi into how much is the magnetic field? 1. So the rho is equal to 5 by pi. 5 by pi is the answer. Let me adjust the options here. Option A is the answer. 5 by pi or pi by 2 pi, sorry. Small correction here. There is option B is available, right? Option B is answer, pi by 2 pi. Fine. So what are the concepts we have discussed in this lecture is, we have seen some concepts. This is a level of questions asked and these are the patterns of questions. Here our intention was to show you what kind of understanding and what kind of approach you should have towards your exam preparation. That is what our intention. Fine. So if you want to have the complete lectures and if you want to subscribe to the course, there is a AS Engineering Academy is providing a wonderful course for your preparation on KPTCL AE. Okay. These are the course details. Pre-recorded lectures are available. Okay. So always AS being always the part of the success of the so many students. Fine. Hope you will going to make this ACE online platform as a part of your success story. Fine. Okay. So these are the course detail. Okay. Anything you want, anything from your side, you're always welcome. Okay, guys. Hope you had a very wonderful time. Fine. Meet you soon again. Thank you. Bye bye.